Are you all with me? Is the whole class with me? We are going to learn how to predict products. So, when we did unit 4 test, one of the questions that had the most point value was, how do you convert the equation into a formula equation? And then balance it and type it, alright? So now, this will probably be a question that's worth a lot of points, okay? So what is the first question that you have to do? We're doing a synthesis reaction. It says you're taking a small amount of sodium and it's being added to chlorine vapor. Are you with me? Alright? So the question says sodium is being mixed with chlorine. Alright? And you would like to know what the product is. Now remember, you know that sodium is a metal. And you know that chlorine is a non-metal. Anytime they just give you a metal and a non-metal, you'll probably make what? You'll make an ionic compound with the two. And what do you think sodium and chlorine will combine and make? What would be the name of the compound that's made between sodium and chlorine? Anybody in class? Sodium chloride. You will make sodium chloride. Alright? So, how do you write it out in the form of formulas? Anybody? Let's get started actually with Demas at this end. What is the symbol for sodium, Demas? How do you write sodium? Na. So, if you look at the periodic table, we know the solid blacks, they're solids, is that right? And then you have the blues, which are liquids, and the reds, which are gases. So what is the state symbol under sodium? You will say it is a solid. Plus, Connor, do you remember, how should I write chlorine?
Chloride.
Well, it's chlorine and it's not chloride. So how am I going to write chlorine? Do you remember your diatomic elements?
Yeah.
Is chlorine one of the diatomic elements?
No.
Let's go and review diatomic elements. Alright? So here is my diatomic elements. So these are my diatomic elements. Do you think chlorine is a diatomic element? You see that? So how do I write chlorine when I write chlorine? How do I write that?
Cl.
Cl followed by a 2. Di means 2, diatomic. Okay? And look at my periodic table, Connor, and tell me what's the state of that substance. Chlorine is a, look at my periodic table because that's color coded, not yours. What is the color of chlorine and what is the state of that gas? And therefore it is? Is it a solid, liquid, or a gas?
Just said it.
It's a, reds are gases. Alright? So it's going to be a,
What is the state of the gas?
oh yeah, that's, that itself, yeah. Sorry, okay? There you go. Okay? Now, so it's asking, here is where students make a mistake. Alright? They will write sodium, they will write chlorine. What will they write as the formula of sodium chloride? I often get NaCl2, which is wrong. Alright? So you have to go back to formula writing with your periodic table. Remember your charge pattern? +1, +2, +3, +-4, -3, -2, -1, and 0. Remember that? All of you remember that? All right. So therefore, what is the charge on sodium? Look, what is the charge on sodium? Sodium is a, look at the periodic table. We just wrote the pattern down. What is the charge on sodium? Sodium is in group 1, therefore it should be a +1. And what is the charge on chlorine? If you look at the pattern, what does it say? What is the charge on chlorine? Chlorine is a -1. So therefore, what is the formula for sodium chloride? NaCl. Alright? And all ionic compounds are generally solids. Okay? So I just predicted my first product. Do you see that? I know it's a metal and a non-metal. The equation is not balanced. So I need a 2 here and a 2 here. And it already said it's a synthesis reaction. Do you understand? Everybody understands?
Is it always a solid or is it most of the time?
All ionic compounds are solids. Okay? Now let's go to the next question that you have in your paper. It says lithium metal is burned in the presence of oxygen. Are you all with me? We're going to do number 2. All right? Let's go here. So it's lithium plus oxygen. Again, whenever I see this, lithium is a metal or a non-metal? Lithium is a metal. That's a non-metal. Oxygen is a non-metal. So DJ, what do you think will be the product formed? Lithium and oxygen will give, what do you think? No, not the formula, just tell me the name of that substance that's formed. Lithium oxide. So it will form lithium oxide. Okay? Annie, what is the symbol for lithium? Li, and lithium is a solid. Is that right? Vanessa, is oxygen a diatomic element? Therefore, what do I write? How do I write oxygen? O2, and it is a solid, liquid, gas. It's a gas. You can look on my periodic table. All right? Katie, what is the charge on lithium?
The charge on lithium is +1.
And oxygen is a?
-2.
Therefore, the formula for lithium oxide will be?
2L plus.
So 2, right? So therefore, the formula will be Li?
2.
Oh, you don't multiply this side. Everybody understands that? Right? This side I multiply by 2. That's a +1, right? And that's a -2. If I look up the charges, correct? I have to balance them, Lena. Is that right? +1 and -2. So what will I end up multiplying this side by? Do I multiply by a 2 to balance it? Is that the number I bring underneath? Everybody understands this? Okay. So the equation is not balanced. All right? Oxygen needs to be a 2, which makes lithium a 4. And now the equation is balanced. Are we good? Do we understand synthesis reactions? So anytime you have a metal plus a non-metal, what will you make? An ionic compound. All right? Let's do the opposite now. We are going to go into decomposition. Again, you will start with an ionic compound. Does that make sense? In a decomposition, this one says molten aluminum chloride is electrolyzed. Don't be bothered by the other words in it. All right, I'm going to go to the next page, and we're going to go to decomposition. It says aluminum chloride. So they give me a word like aluminum chloride, and I'm predicting products. Immediately, I'll be like, oh, this is a metal. This is the non-metal. Now I have to break apart and make the products. So Salim, what do you think aluminum chloride will break apart into? It'll break up into, name the elements first. No, don't give me the formula. Just give me the name. Aluminum plus chlorine. Okay? Are we good so far? It's a step-by-step thinking process. Now, this is an ionic compound. So again, whenever it's an ionic compound, I have to go back to the periodic table and look up the charges before I write the formula. So aluminum has a charge of +3, chlorine has a charge of -1. Did you locate that on the periodic table? I'm writing this down so that you can write it on a piece of notebook paper. Everybody should be writing with me. As I write, you write. Can you all write decomposition now and write what I'm writing with me? DJ, you too, please. Everybody should be writing. Okay? So, Morgan, which side should I multiply? Chloride by 3. And what is my final formula for aluminum chloride? Al. L is chlorine. 3. Very good. All right? So that's how I write my formula for aluminum chloride. Everybody got that? Don't rush the process. Yes.
So, what is like non-metal and metal? Like, what are those called? Are they groups or are they?
Ionic compounds?
No, like,
Polyatomic ions, you mean? Then?
like identifying it as a metal or a non-metal. What's that called?
Identifying the elements in the given compound as a metal or a non-metal. Am I answering your question?
Yeah, because like you can identify states of matter
Mm-hmm.
as like solid, liquid, gas.
Mm-hmm.
But what is identifying like whether it's a metal or a non-metal?
Just identifying the type of element.
So type.
It's the type of element. All right? All right, Mike. Moving on. How do I write aluminum? Al. So here is a question for the entire class. Aluminum on the periodic table has a charge of what? +3. Is everybody listening? This is a very common mistake on all my tests and quizzes for which kids lose points. Do I ever write aluminum as Al3? Or can I write it as Al +3? No. When it's an element, all you will write is Al. Nothing else. If I see this, I will not give you any credit. Make a note of that. I need you to be writing these things down as I say it. There is a process of learning. If you write things down, it etches in your memory. Otherwise, it evaporates very quickly. DJ also should be writing. Miss. DJ, get rid of these. I would not. It's okay to doodle, but I need you to focus on this.
I wrote it all down, look.
Okay. On a notebook paper, why not there? There's more space there, right? That's why I gave you notebook paper, right? Okay. So, plus, we are moving on. Haley, I'm going to go back to my periodic table. So, periodic table is my friend to get me my good grade in the class. Tell me, is chlorine a diatomic element?
Oh yeah.
Are you looking at the 7 that I drew? Is it a diatomic element? So, going back, how am I going to write chlorine? Cl? If I say it's a diatomic element, Haley, then what should I be writing? Di means 2. So where should I be writing that 2? In the bottom of chlorine. Got that? Anytime you recognize an element as being diatomic, you should be writing the 2 underneath it. Do we understand this? Okay? All right. It says molten aluminum chloride. Does it say that? Molten means it's liquid. What does molten mean? It's liquefied. Alright? Karina, what's the state symbol for aluminum? Is it a solid, liquid, or a gas? It's a solid. And Lena, what is the state symbol for chlorine? Is it a solid, liquid, or a gas? How will I know to find if it's a solid, liquid, or a gas? Where will I look? Look at the periodic table on my wall. Don't look at your periodic table. What is the color? So therefore it is? Therefore its color is red. Therefore the state of the substance is gas. Okay? So the equation is not balanced. Alright? Chlorine is a 3 there. So I'm going to put a 3 here, making that a 6. Alright? So I'll put a 2 there, and I'll put a 2 there, and my equation is balanced. So what are the two types of synthesis and decomposition reactions you will get? Ionic compounds. You'll always get ionic compounds for synthesis and decomposition. Are we clear? Do we all understand this? Okay. We're moving on, and we're going to do single replacement reaction now. Single replacement reaction. Okay? Again, whenever you look at a single replacement reaction, you have to look at the substance that's given. It says liquid bromine. Is bromine a metal or a non-metal? Tyler, is bromine a metal or a non-metal? Where is bromine located on the periodic table? Do we know to locate metals?
Located on the non-metal.
Tyler, please. So, do you see that bromine is located on this side of the periodic table, right? Therefore, it is a non-metal. So, I'm going to do a little trick to help me out. If it's a non-metal, I'm going to write it with a red colored pen. All right? And so there is bromine. It's a non-metal. Plus, what is the other substance they have given? Let's look at the other substance. It says sodium iodide. Sodium is a metal. Iodine is a non-metal gas, right? So metal plus non-metal, that's an ionic compound, correct? So the way I'm going to write it out is, Tyler just told me sodium is a metal and iodine is a non-metal. Do you see how I have color coded a single replacement reaction? What did I do with my non-metals? I made them red. What did I do with my metal? I made it black. Now remember, in a single replacement reaction, all right, a non-metal can only replace a non-metal. I'm kind of going to say this in a very crude way because kids make links with what I say, all right? But it doesn't mean to offend any student or anything like that. No offense meant. I generally like to treat my metals as my males. My non-metals are my females. So in chemistry, you can never ever put two males together or two females together. Okay? What is the reason behind it? It's because metals lose electrons, non-metal gain electrons. Does that make sense? So, who's the next kid? Kitty. Having said that, so, or if you want to take another situation, because kids make links with all these things, it helps them understand. It's not to put down or put up a student. Please bear with me as I teach this class, all right? It's not to discriminate or do anything like that. Please understand that let's look at it as your best friend stealing your date type of situation, all right? Now, this is a couple. This is a male and a female. Are you with me? So, if you switch products, Katie, what do you think the product should be? What do you predict the products to be? So this is a female. Let's say she's female 2. This is female 1. And this is the only male. Right? So now they have to switch. And remember, you can't put 2 females together or 2 males together. Very good. Iodide will become iodine plus, what is the other product? Sodium bromide. Did we understand how I switched and how I made the product? Do you all understand this? Okay? Now, I'm going to go back and write the formulas. David, is bromine one of my diatomic elements? Is bromine a diatomic element? Is it a diatomic element? Is it in that 7? Therefore, how do I write bromine? With a 2 in the bottom. Is that right? Plus, Zoe, I have to write the formula for sodium iodide. What is the charge on sodium? Sodium is a, and sodium, what was the compound again? Okay. Iodide is a -1. Is that right? Right? So what is, if sodium is a +1, iodine is a -1, what is the formula for sodium iodide? NaI. Very good. It's NaI. Alright? Moving on to Abby. Abby's iodine, a diatomic element. Is it a diatomic element? So how do I write iodine if it's a diatomic element? I2 plus, sodium is a +1, bromine is a -1. Gavin, what is my formula for sodium bromide? NaBr. Alright? The equation is not balanced. Bromine is a 2 there, so I need to put a 2 there. Sodium becomes a 2, that becomes a 2, and my equation is not balanced. Are we good? This is the product of a single replacement reaction. Are we good? Are we good? We're coming back to Demas, and we'll go and do the next one on a single replacement reaction. An aluminum strip is immersed in an aqueous solution of silver nitrate. I know I haven't done the phase symbols, but we can do that a little later. This is more intense in understanding what the products are. So aluminum, Demas, is it a metal or a non-metal? Aluminum is a metal. So I'm going to use black for aluminum. Every single replacement reaction, I should be aware of my black and my reds. What is the other product? The other one was silver nitrate. Is that right? Alright? So silver is a metal. Is that right? So silver, I'm going to say, is my metal. And nitrate will therefore be my female. Is that right? Are we good? Are we good? So here is a situation with 2 metals and 1 non-metal. Or in other words, 2 males and a female. Alright? Connor, you want to predict the products? No, I don't want the symbol. So what is on the product side? How will they switch and how will they make products? Silver was going out with nitrate and aluminum was by itself. So how will they switch? So what will be the product? Silver plus aluminum nitrate. He gave them both. Plus aluminum nitrate. Are we good? Do we understand this? Is everybody okay with the products being predicted? Do you all confirm that these are the products that should be formed? You'll always write the metal first. Is that understood?
Write it with letters.
Yeah, let's write the symbols.
Like A, E, kind of stuff like that.
Oh, you want to do it like that? You should make sure that you start with the metal and not like that. So if you want to call it A and you want to call this B, C, so you will switch to A, C, and B will come out. Does that make sense? Does that make sense? Okay?
Yes.
Now, who's the next one? Look, how do I write aluminum? AL. Do I include any number, anything underneath? You don't include anything. You just write AL plus, he's not here, so I'm going to move to Annie. Annie, what is the charge on silver on the periodic table? Here is silver. Silver is always a +1. All right? Do you remember your polyatomic ions? Silver is always a +1. What is your polyatomic ion? Do you remember your Ono-Sokopo clone? Do you remember that? It doesn't hurt to write that down somewhere on the top of that page or something like that. I'm going to write it on the sideboard. This you never ever forget for the year that you're in chemistry. All right? Let's make sure we write that again. O, no, so, co, ho, clone. Is everybody writing this? Is everybody writing this down? It doesn't hurt to review. -1, -1, -2, -2, -3, -1, +1. Skip 3, 4, 3, 4, 3, 4. Is that right? So Annie, what is the symbol or charge for nitrate? Nitrate is a -1. So what will the formula for silver nitrate be? Ag NO. What should I remember to include? 3. All right? So Vanessa, how will I write silver on the other side? It's just silver. Ag plus, I now have to write the formula of aluminum nitrate. Remember, aluminum is a what charge? The charge in aluminum is a +3 and nitrate is a -1. So which side am I multiplying? Which side am I multiplying? The nitrate side by 3. So Katie, what is my formula for aluminum nitrate?
Your formula for aluminum nitrate would be Al plus AgNO3 would turn into Ag plus AlNO3.
Is it just AlNO3?
Probably not.
So if I multiply this side by 3, how do I show that? What should I do? Include brackets here
Yep.
and make the nitrate a 3.
Yay, yeah.
Everybody understands this? Okay. Now let's go down and the equation is not balanced. All right. So nitrate has to be a 3, which will make the silver a 3, and now the equation is balanced. Are we good? This will be a solid. If you want state symbols, this will be a solid. This will be aqueous. This will be a solid, and this will be aqueous, meaning it's dissolved in water. Okay?
It's just a liquid. Would you just put
No, liquid is different from being dissolved in solid.
Yeah, I
It's an
know.
ionic compound, which was a solid. Now dissolved in liquid makes it aqueous. Different.
Okay, so for
Mhm.
synthesis and decomposition, if they're both going to end up with a solid product because they're both ionic compounds.
That is correct.
So single replacement, what's that one? Is that
Single replacement, the metal will generally be the solid, and the compound will generally be aqueous. Okay.
is it what kind of compound?
It's an ionic compound that's dissolved in water. Okay? All right, moving on. Are we good with single replacement reaction and how to predict products? Isn't that a little hard? We are now moving into double replacement reactions. No. Double replacement reactions. Okay? Let's look at an example for double replacement reaction. Okay? We are doing the first one. An aqueous solution of iron 3 sulfate is added to a solution of barium iodide. Okay? So, selenium, iron is a metal, correct? Any negative polyatomic ion will be the female portion, alright? So, I have iron sulfate, iron 3 actually, is that right? Is it iron 3 sulfate, guys?
Yep.
Iron 3 sulfate plus what is the other substance? What is the other substance? Barium. Barium is the metal and iodide is the non-metal. This is a double replacement reaction. Are you identifying the metal and the non-metal or the male and the female? Remember, you cannot put two metals together or two non-metals together. This is like going on a double date, right? And then the partners switch. So, Salim, what are the products of this reaction? Iron was going out with sulfate, barium was going out with iodide. Tell me what the new products are. Salim, please. Iron with whom? Iron 3. You're putting two metals together.
Get it right.
You can't do that. Ah, iodide. Very good. Plus, what is the other product? Ah, you always got to write the metal first. Can't write the non-metal first. You got to write the metal first. So what is the metal? Barium.
3.
No, barium doesn't have a Roman numeral. Okay, the way I wrote it. My bad. All right, it's barium. And my non-metal portion is my sulfate. Are we good? Do we understand this? All right. So now it is Morgan's turn. You're going to write the formula of these compounds. What is the...
Does it matter which, like if you wrote it barium sulfide
Doesn't matter.
first?
Doesn't matter. Okay? So iron, did you all listen to that question? That was a good question. Okay. So iron has a charge of +3. What is the charge on sulfate? It's a polyatomic ion, correct? So, Morgan, please, -2. And do they balance? Do I have to multiply?
Iron by 2.
Iron by 2, sulfate by 3. So, tell me what is the formula of iron 3 sulfate? Fe.
Stop talking. Confusing me. And then you're gonna put the 2.
Very good. Sulfate is,
I don't know.
there it's right there.
SO.
SO. Give me its hands. Don't forget its hands. I call the subscripts the hands.
Okay, so that's just 4.
Okay. And then what?
3. So parentheses and 3.
Okay.
And that's
Plus, let's go to Mike next. Mike, the charge on barium is a +2. Iodine is a -1. Do we all see where I'm getting these charges from? Everybody recognizes? Which side should I multiply? Right? So what is my formula for barium iodide? Shh. Mike, please. Ba I2. Very good. We're moving on. So we are now with Haley. Haley, what is the charge on iron? It's a +3. And the charge on iodide is? -1. So which side am I going to multiply? By 3. So what is my formula for iron 3 iodide? Fe I 3. Very good. Plus, moving on, Karina, what is the charge on barium? What is the charge on sulfate? Huh? -2. So what is the formula for barium sulfate? Ba SO. Sulfate is written here. SO4. Very good. All right? Are we good? Yes.
Right. So jumping back on like the composition and synthesis, it's a metal plus a non-metal equals.
An ionic compound.
So is that going to be a metal or a non-metal, or does it change?
It's always a metal followed by a non-metal. We're going to do very simple ionic compounds. Okay? Now, did I answer the question, Morgan? What was the question again?
So you're adding a metal plus a non-metal,
Uh-huh.
and then the result of those two is
Is
metal.
a single compound.
Single.
It is a single compound, but is that single compound a metal or a non-metal?
It's an ionic compound which is made of a metal and a non-metal together.
So it's a there
You
you go.
don't write it as an element. There is no plus in
There
between.
you go.
Do you understand? When you separate, so going back to what she's asking, let's go back. So when I write the metal, I have a plus in between, which means it's just an element.
Combining the two.
Yeah.
And this is a non-metal just by itself. And now there is no plus in between. And I get the formula by looking at the charges on the periodic table. Did I answer the question now? Okay. Let's move on. And we are going to the double replacement reaction. Okay? The equation is not balanced. So I always like to balance my polyatomic ions first. That'll be a 3, making the barium a 3 here, making my ion a 2 here, and that'll be a 1. Are we good? And I'm not going to go, it doesn't say much. I'm not going to look for state symbols in a double replacement reaction. Okay? I'm going to expect you to know that. Okay? Shall we do one more double replacement reaction? We're going to do the next one, which is, Lena, is rubidium a metal or a non-metal? Look at 37. Rubidium is the metal. And then there is phosphate, so phosphate will be the non-metal, right? The metal has to be with a non-metal. Look at titanium. You always start with a metal. It's 22. It's a metal, correct? So here are the reactants. So you have rubidium phosphate, okay, plus titanium. Remember, what was the non-metal portion of it? What was the non-metal portion? It is titanium 4 nitrate. Okay, titanium 4 nitrate. And now, Lena, help me predict the products. What do you think the products will be? Rubidium is going out with phosphate. Titanium is going out with nitrate. Very good. So it's going to be rubidium nitrate. And what is my other product, Lena? Titanium. Yeah, titanium 4 phosphate. Are we good? Okay. So Tyler, what is the charge on rubidium off of the periodic table? Rubidium is located right here, so what is the charge? +1. Okay? So rubidium is a +1. And phosphate, look up there and tell me what is phosphate's charge. Here, the polyatomic ions. What is the charge of phosphate? -3. So which side should I multiply to make it even? The rubidium side. I multiply the rubidium side by 3. So tell me what is the formula for rubidium phosphate. I write the symbol for rubidium is Rb. Am I multiplying the rubidium side by any number? So do I write that as a subscript here? And then am I multiplying the phosphate side? No. So what is the formula for phosphate? PO4. That is rubidium phosphate. Okay? Moving on. Katie, what is the charge on titanium? Titanium is a? What does it say there in the name? Titanium. It's a 4. Okay? It's a 4. And what is the charge on nitrate? -1. So which side am I multiplying, Katie? It's a +4 and a -1. Which side am I multiplying? The -1 side by a 4. Is that right? So what is my formula for titanium 4 nitrate? It's going to be Ti, correct? Am I multiplying Ti? And then nitrate is NO. And do I repeat it? Am I multiplying the nitrate side? Am I multiplying the nitrate side? So how many times should I repeat that? 4. Very good. Okay. Moving on. David, charge on rubidium. Charge on nitrate. So I'm not multiplying any side. So the formula is Rb. Nitrate is NO3 plus Zoe. What is the charge on titanium? And phosphate is -3. So what am I multiplying each side by? Zoe, please. What am I multiplying this side by? And that side by 4. So what is my formula for titanium 4 phosphate? Ti3 phosphate is PO4. And how many times do I repeat it? 4 times. Are we good? Do we understand that? Do we all understand? Yes, Maureen.
Same question.
Uh-huh.
So, single replacement, that's an ionic compound dissolved in water with a double replacement.
Double replacement is 2 ionic compounds. And they will exchange places. The metal and the non-metal will exchange. All right? So, this is not balanced. All right? Nitrate is a 4. Rubidium is a 3. So, that's going to be complicated. So, let's say titanium is a 3. So, we may want to give titanium a 3 here, which makes the nitrate 4 times 3, 12. All right? Rubidium will be a 4, and that's just a 1. Are we good? That's the balancing equation. So all this is not going away. Are we comfortable predicting a double replacement reaction? All right. The last and final one. Okay, the last and final one is combustion.
Lunch is at 1:21.
That's the most confusing one.
All right. So let's go to the very last one. We're going to say propane is burned. They've given us the formula. It's C3 hydrogen 8 plus. When they say it's burnt, what should you remember to include? Oxygen. Burnt means oxygen plus O2. Alright? So it's Abby's turn. What are the products of a combustion reaction? Always Abby. What does a carbon hydrogen compound combine with oxygen to give? Anybody remembers? It's water. Very good. And what is the other product? It's always carbon dioxide. Remember, the carbon and the oxygen is carbon dioxide. The hydrogen and the oxygen is water.
So combustion is always.
It's always water plus carbon dioxide.
The product is always the same.
It's always going to be carbon dioxide and water.
So
Okay?
that means that
The reactant can be anything. You have to remember to add plus oxygen and then it's CO2 and H2O. Are we good? The equation is not balanced. Combustion elements are hard to balance, right?
Yes.
All right? Are we good? Do we understand? Guys, you're not coming back to it till we do a lab. Not next class. I'm not going to be here. Miss Maya will teach the class and give you the quiz. We'll do this a later class. You're coming back to this.
Do we need to burn something?
Hopefully.
Hello, man. Calm down.
So I'm going to post this